Prove that a cyclic parallelogram is a rectangle. The diagram is very simple, so I'll do it off. We have to prove that we have a rectangle which is a parallelogram to begin with, and it's cyclic. So I drew a cyclic parallelogram which turns out to be a rectangle. So let's begin by talking about the diagram. Let's consider a circle with center O. Let ABCD be the cyclic parallelogram. Now, what is that we need to prove? We need to prove that ABCD is a rectangle. Okay, so rectangle and parallelogram, the difference between them is what you guys have to search first. So let me give you guys a clue. The clue being, first one is check the difference between a parallelogram and a rectangle. Okay, so what makes a parallelogram a rectangle? Second is about cyclic quadrilateral. Right, I would like you guys to find the property, especially related to angles. That's the biggest clue. I hope you guys did. So what is the angular property of a parallelogram? Well, the angles are equal. Why are they equal? Well, opposite angles of a parallelogram are equal. I mean, actually, the way I put it across is kind of funny. Anyways, angle A is equal to angle C. Why are they equal? Because they are opposite angles of a parallelogram. That's what I meant. Now, angle A plus angle C is equal to 180 degree. But why is this so? Because they are opposite angles of what? We already wrote parallelogram, so it has to be a cyclic quadrilateral. And from 1, if I substitute things, so from 1 I have angle A plus angle A is equal to 180 degree. So 2 times of angle A is equal to 180 degree. Therefore angle A is equal to 90 degree. So if one of the angle is 90 degree, what does this make the entire parallelogram to be? Therefore ABCD is a rectangle. Why is that? Because as one of the angle of a rectangle, one of the angles of the parallelogram is 90 degree, and that's your proof.